Bismillahirrahmanirrahim. Assalamu alaikum. My name is Engineer Inamur Rahman Shahid, and today we are going to discuss a very basic topic, which is we will see the behavior of PMOS in both series and parallel connection. So before moving forward, we should know that we have basic two types of transistors, which is NMOS and PMOS. In the next video, we will discuss the behavior of NMOS in both series and parallel connection. So now, first of all, what is the basic difference of NMOS and PMOS? As we know that these NMOS and PMOS are three terminal devices having gate, drain and source. Whenever we apply the input to the gate, then according to the characteristics of NMOS or PMOS, the drain and source will be short circuited or will be open circuited. So now NMOS is basically a high voltage device. Whenever we apply the high voltage at the gate, the drain and source become short circuited. As we can see in the figure, whenever the gate voltage is 0, means low voltage is applied to the NMOS, the drain and the source become open circuited, and whenever the high voltage is applied to the gate, the drain and source become short circuited. But the PMOS is totally opposite of the NMOS. Here we can see there is a little bit of knot in the diagram. You can see, means whenever we apply the high voltage to the gate, and here we have a knot, so it will invert this high voltage, means whenever we apply the high voltage, then it will act as open circuited, means drain and source will be open circuited, and whenever our gate will be 0 or low voltage at the gate is applied, the drain and source become short circuited. As we can see in the figure, whenever we have a gate is equals to 0, means low voltage at the gate is applied, the drain and source become short circuited of the PMOS, and whenever we applied the high voltage at the gate, the drain and source become open circuited, because here we have a knot, as we can see in the figure. So moving forward, here we can see the two PMOS are connecting in series. Whenever we connect two PMOS in series, then they will act as NOR function, NOR gate. How? Now we will discuss this how. I will also show you the simulation in software of this PMOS connection in series and PMOS connection in parallel. So first of all, discuss a PMOS connection in series. Look students, here we have two PMOS, and so we have two inputs. Now whenever, as I said earlier, whenever we connect the PMOS connection in series, the PMOS in series act as a NOR gate, act as a NOR function, means the opposite of all functions. How? Now we are going to discuss. Here students, look, we have two inputs, input A and input B. As I told you earlier that the PMOS is a low voltage device, means whenever we apply the low voltage at the gate, the drain and source of the PMOS become short circuited. As I mentioned earlier, as you can see here, the drain and source become short circuited whenever we apply the low voltage at the gate. So now here we have both input A and input B are 0. Here at the source terminal we have output connected, which is LED bulb, so that we can see our output. Now both the inputs are 0. When input A is 0, you can see the drain and source of the first PMOS are short circuited. Similarly, the drain and source of the PMOS of second PMOS are connected, are short circuited. Now here we have a biasing voltage plus 5 volts. It will go from this path to the output, and we can see that whenever our both input voltages are 0, our output will be 1, because both PMOS are short circuited, and there is a clear path from this biasing voltage plus 5 volts to the output. So now here is the truth table. Now students, see, when both the inputs A and B are 0, our output will be 1. Now discuss the other case when our input A is 0 but our input B is 1. Here is the case, student. You can see we have two inputs. In this case, input A is 0 but input A is 1. Means input A is low voltage and input B is at high voltage. The first PMOS becomes short circuited. Their drain and source become short circuited because of low voltage. PMOS is a low voltage device. Similarly, the drain and source of second PMOS become open circuited. Why? Because here we have a high voltage and we know that PMOS is a low voltage device. Here we have a not circle, as you can see in the figure. So whenever we apply the high voltage here, you can see the drain and source become open circuited and the path break, circuit path break here. You can see this plus 5 voltage can't go to the output because our path is break. So whenever we apply the input A is 0 and input B is 1, our output will be 0. LED is not glowing, as you can see. So 0, 1, 0. This is our truth table for this condition. Now discussing the third case here, when we apply the input A is high and input B is low. Now students, you can see when we apply the input A is high and the input B is low. Similar to the previous case, you can see there is a high voltage. The first PMOS become open circuited, their drain and source become open circuited, and you can see when we apply the low voltage to the second PMOS, the drain and source of second PMOS become short circuited, but as you can see the path is break. So this voltage can't go to the output. So that is why in this case we have also the output 0. So whenever we apply the input A is 1 and input B is 0, we can see our output is 0. Now discussing the last case, when our both inputs are 1. When our both inputs are 1 means high voltage at the gate terminal. Now high voltage at the gate terminals mean both transistors will become open circuited. Both PMOS become open circuited. As you can see, first PMOS is open circuited and also second PMOS is open circuited. Means the voltage at this point can't go to that point, because both the circuits, both the PMOS become open circuited and our path is totally break, not only from this part but also from this part. So whenever we apply the high voltage at the gate on both terminals, we have output voltage 0. So now we will see the total truth table of this scenario. Here we have the truth table of all the conditions of this scenario. We can see when our both inputs are 0, we have output 1, and when only one input is 0, here our input A is 0 and input B is 0, we get the output 0. And similarly, when both voltages are high, means the voltage at the gate terminals is high, then also we will get the output voltage 0. And this is the function, this is the truth table. That truth table is very similar to the NOR function gate truth table, which is totally opposite to the OR function. In OR function, what we have, if our one input is 1, if our only means single input is 1, then our output becomes 1. But here NOR gate is totally the opposite of the OR gate. In NOR gate, if we both have 0 inputs, then our output will be 1, and if any of the input is 1 or both the input is 1, then our output will be 0. So what we see here is that whenever PMOS connection is we connected the PMOS in series, our output will be acted, this scenario is acted as a NOR function. So series connection of PMOS acts as NOR function.